Hey, what's up, guys? Welcome to Chapter 1, Lesson 1 of this Intro to Electrical Engineering course. My name is David. Hopefully, I can plow you guys through this course a little bit, just kind of show you what's up in the electrical engineering world. Alright, then, let's get started with that actually. Let me just get a pen in a different color. So, I'm sure, well, hopefully, you guys have all been exposed to some basic chemistry in your lifetime at one point or another. I hate chemistry so much, but it is rather important. At least the basics are. So the basic model of the atom is you have, I'm sure you probably already know this, but basically you have this center here called the nucleus, and then swirling all around in weird shapes and weird patterns are little electrons. Um, Now, just so we can see it more clearly, on a 2D flat diagram, we can just say that the electrons go around like this, even though they don't at all, but just to simplify things, because I want to explain a few concepts that you probably already know, but I might as well go through it. Alright, so you have electrons, and I'm gonna attempt to explain what they are. I mean, nobody really knows what they are, but we do have some definitions pertaining to them. But anyways, you have the electrons on the outside of this thing called the nucleus. Draw another line. But this thing called the nucleus is actually composed of smaller parts, smaller particles actually, of protons. I don't know what that line is. Let me see if I can erase it. Huh. That's a strange anomaly. I have no idea how that line showed up. But anyways, you have protons, which I'm going to denote with positive symbols, plus signs, and you also have neutrons, which don't have a symbol because they don't have charge. Now, right away, the next thing to think about is charge and what exactly it is. So, is it possible to just make a new slide? Aha. So, so what is charge then? This is actually a much harder question to answer than one would think. I don't know how to put it. Let's say, in simplest terms, charge is the static that you feel on a balloon after you rub it with wool. It's the stuff that flows through wires. It's the stuff that makes electric fields. I know this is a terrible definition, but honestly, this is the very best we have because charge is just a fundamental thing. It's like mass. You can see how it interacts with the outside world. Like you can weigh, something, a piece of matter. You can weigh it, but what is that number? Well, it's mass times acceleration, right? Weight equals, well, it's a force, and you know that a force is mass times acceleration, and acceleration is already some number, and then mass, what is mass? It's just another number. There really is no good definition for it. It's just a fundamental, um, I guess you can say fundamental property of the universe. So you have, like I said before, you have the nucleus composed of protons and neutrons. Then you have electrons out here doing the dirty work, actually, as you're gonna see. But okay, so charge. Why do I bring this topic up? It's actually extremely important. Now, it turns out that every particle, so here's the electron, has this property charge, and for each one, for each particle, it's a different number. So proton and neutron. And it turns out that this number is actually a ridiculously small number. Well, it's only small because of how we define it, but it's basically okay. So for an let's start with the proton actually. For a proton, we say that each proton has 1.6 times 10 to the negative 19th. Did I say large number? I meant small number if I said large. So we have this unit here, C, which means coulombs. It's just a standard unit of measuring charge. How we came up with this number, it's going to take a lot more explaining, and it's not really that important. It's just important that you know this number. The other really important thing is that every proton has 1.6 times 10 to the negative 19th coulombs of charge, and every electron has, you guessed it, negative 1.6 times 10 to the negative 19th coulombs. This is an extremely important, it used to be idea at some point, but it's through many experiments and whatnot, it's been proven to be correct, the correct number, within some percent of an error, but it's close enough. And it turns out that every electron has this, and you'll see why this is really important later on. It's not that it's important, it's just it's lucky that it's this way, because it makes it easy for us humans to exploit the property. And then for a neutron, if I can find my pointer, where is it? It's just 0 coulombs. A neutron has no charge whatsoever, or at least not in the way we define charge. And actually, because of the neutron, you know how you have the nucleus in the middle? And like I said, there's that line again. Like I said, there are protons in there, and then there's also neutrons. Actually, this leads right into the next topic, which I was going to talk about, and it's so basically because of these neutrons, the nucleus can stay together as a whole. As you can see, as I've drawn in this picture, and as you'll find in many different textbooks, this is kind of the picture that everybody wants you to understand, and it's basically just saying protons and neutrons are really close together in the middle here, and then electrons are just out here doing their own thing, you know. So that actually leads me into the very next idea,